Hello, this is Hanbeom Chang from State University of New York, Korea. Today we'll review our research about 3D reconstruction by looking instantaneous blind spot detection for indoor SLAM and mixed reality. Here are the table of contents starting from background to the conclusion. Throughout the years, due to the lack of inspection and assessment, buildings have collapsed and caused serious damages. Now, systematic and regular structural assessments are required. Structural assessment have been developing from NDT to PHM. Now, remote visual inspection is a new way to assess thanks to the development of computing powers and vision sensors. Starting from structure from motion, SFM, 3D Gaussian splatting recently, and SLAM are the 3D reconstruction methods, and we will focus on SLAM. However, current limitation on SLAM and indoor scanning, adjacent sensors matters. It causes rapid scene changes, reducing the overlap between the scenes. This causes drifting double walls and blind spots. As a result, we developed the LiMRSF system to fuse the vision sensors and visualize it through mixed reality device to detect and visualize SLAM errors instantaneously. This will include LiDAR-RGB scanner detecting and highlighting blind spots and visualize through MR device. So this is our system overview, and the research is divided into 3 stages with the loop to generate a high-fidelity indoor dataset. In stage 1, we calibrate intrinsic parameters of the camera, including the focal length, principal points, and the distortion coefficients. And after that, we calibrate the extrinsic calibration. This is a process using Coit-3's extrinsic calibration to overlap the coordinate of LiDAR to the camera's coordinate system. Lastly, we use R3 Live to create a color point cloud with our LiDAR and RGB camera. In stage 2, to transform point cloud to mesh and detect and highlight the blind spot on top of the mesh. For generating a mesh, we remove the outlier in the point cloud and compute the normal vectors for each point. We detect the blind spots with lower mean density compared to the threshold, and Poisson surface reconstruction creates watertight mesh. This will be later simplified for MR visualization. Lastly, the highlighted mesh is transferred to Unity app, which is deployed to the MR device through ROS TCP network. The user will manually localize the map on top of the real world for easy localization. We validated our system in our lab environment with FLIR Blacklight S, Oster LiDAR, and Microsoft HoloLens 2. These results show highlighted blind spots on top of the mesh with simplified version for MR headsets. Our blind spot detector has 76% of F1 score, aiming for the lowest false negative to minimize missing any critical blind spots. For evaluating the similarity between the original and simplified version, we validated with SSIM, PSNR, and mean square error. As a result, all the values were higher in simplified mesh due to the reduced high-frequency noises of the mesh. So this is our last slide. Please visit our website and YouTube for more researches. Thank you.